Good evening, students. Today we are going to do the 11th class of the NEET for the NEET exam, and last class we have done I think chemistry topic. That only we are continuing. Now today some students they were asking what is isomerism and what are isomers and what is geometrical isomer and optical isomer with respect to the coordination compounds, and the coordination compounds that will be dealing separately there. But for that there is two questions, two important questions they are going to appear in that NEET exams. Majority of the students they will be finding difficult in solving that type of question. One is geometrical isomerism and optical isomerism. Professor JAIKUMAR, head of the department, again he came for the rescue to solve this topic, and detailed discussions for 5 hours we have discussed, and that synopsis only I am going to do today. And today we will discuss that weak field ligands and strong field ligands. See, this is very important to know the strength of the ligands, and this classification depends upon spectrochemical series, but we don't want to discuss that spectrochemical series. Whatever we know, from that we start operating it. Okay. Here the ligands, the donor atoms are halogens, that is fluoride, chloride, bromide and iodide. It's called halogens. Oxygen or sulfur. See, oxygen and sulfur, right? Oxygen and sulfur. These are called weak ligands. That means the donor atoms are what? Halogens, oxygen or sulfur. They are called weak ligands. Let us see some examples so that you will understand better. See example. These are the example: fluoride, chloride, bromide, halogens. Halogens are salt forming compound. This is called weak field ligands. Even OH. Here oxygen is the donor. Here this is the bidentate. Here which is the donor atom here? If a sulfur is the donor atom. If cyanide, it is going to be a stronger. Oxalate ion also. You know oxalate? How the oxalate? This is the bidentate ligand. Here these two oxygen donate to the metal because oxygen is the donor, therefore it is a weak field ligands. Okay. Here sulfur is the donor, not cyanide. Here oxygen is the donor. In the case of strong field ligands, what are the donor atom? Donor atoms, carbon or nitrogen and phosphorus, they are called strong. Strong field ligands. Example, cyanide. This is ambidendant ligands. Here nitrogen can be a donor or carbon can be a donor. See, it is like, see, this is the carbon is the donor. If nitrogen is the donor, I will write like this. Here nitrogen is the donor. Here carbon is the donor. Therefore, CN, NC, here carbon monoxide, nitrogen is the donor here. Ethylene diamine, here ethylene diamine, you know, right? What is the structure? CH2, NH2, here NH2, nitrogen is a lone pair, it donate to the metal. The donor is nitrogen. This is a strong ligand, right? See, dimethyl glyoxylate ion. This also, here what? COO, CH2, NH2. Here nitrogen is the donor. What is EDTA? You know what is EDTA? These and all we have done in the previous classes. Here dimethylate glyoxyl ion, right? Dimethyl. Here also EDTA, nitrogen is the donor. You know, triphenyl phosphine. Here phosphorus donate. It is a strong ligand. Again, you know, trimethyl phosphine. Because trimethyl phosphine, because it contains phosphorus, right? So many things you have to remember. This you already studied. That is the reason I went very fast. I don't want to discuss in a detailed way. But now you have to be very careful here. Which is the donor? Carbon is the donor. Here nitrogen is the donor. Right? Here nitrogen is the donor. Therefore, go through the notes or lessons, whatever, or the textbook. Then you read this. It will be easy for your NEET. See why we are using this VBT, valency band theory, CFT, crystal field theory. There we are going to use it. In valence field theory, we are going to have weak field ligands. There I am going to choose two, right? Halogens, fluorine or chlorine or bromide, whatever this one. Halogens. And for the weak field, for strong field ligands, I am going to choose cyanide and even neutral molecules, say ammonia, right? The nitrogen is the donor. Here also nitrogen is the donor. Cyanide, we are going to discuss that. And this just at present you remember a few, not such a detail. But in the NEET examination, you must know the expanded form of all this. Alright? Identifications and the detail, how it forms, the bond formations, and which is the donor. And here nitrogen is the donor. Find out what is the other donor. All that is important. I'm going to write a few things now here. Just let us test. 1, 2, OCN, 3, ONO, 4, NO2. Now here sulfur is the donor. Now here oxygen is the donor. The questions are, is it not the donor? Is it not the cyanide is not a donor? Now it has become a confusion. Which is the donor? But we can identify it as a donor provided, see, suppose they give like this. They give this compound CO NH3 5 OCN, right, 2 plus, and same thing, just slightly interchange, CNO. What is the difference between these two? What is the difference? Here oxygen is the donor, not cyanide. Here cyanide is the donor. Can you follow? Which is facing this? That is the donor. In that way we can say it is the donor. Okay. Which is the facing the front? Here, no, sulfur is the donor. Here oxygen is the donor. Which is the strong field ligands. These are called. They may ask you question. Out of this, which is the strong field ligands? These two at present. See, oxygen is a donor, therefore it is a weak field. Carbon is the donor, it is a strong field. Here what happened? This is oxygen is the donor, here nitrogen is the donor. Whichever the front they put it, that is the donor. Simple. For any competitive exams, follow this. And you must know which is the weak and strong. This is strong, this is weak. See this one. Depends upon the trends.